A tricky 6 marker, and it's explain how a fluorescent watch works in terms of absorption and emission of light. So we're going to have to start talking about electrons and energy shells and all those sort of things. So if I just draw an electron, I'll be using E-. What's going to happen is it's going to absorb some light of whatever frequency it is. And when that happens, it's going to get excited. Woohoo! Off it goes. And let's say it goes to a higher energy level there. And let's say there are others in here like this. Well, it's not going to hang around at the top for very long. We get the idea. The electron absorbs the energy. It gets excited. And then what's going to happen is it's going to fall down. So if we imagine now, say it's absorbed UV light. If it fell all the way straight back, it will now emit UV light. It'll give out the same energy that it absorbed. If it did it in small little steps, we're going to get less energy. And what's going to happen is rather than high frequency UV, we're going to get longer waves such as red light. If it did it in slightly bigger jumps, then we might get some blue light. But the crucial part is a large jump gives you a short wavelength or high frequency. Little jumps have less energy. You can see we've given the electron potential energy. Little jumps make longer wavelengths. So I'm going to tidy all of that diagram up, and then the keywords will come in, and just be good at this. So I'm going to draw some energy levels, and I'm going to put an electron here. So it's going to absorb some light. So I'm going to call that light. It's going to get excited. It's now going to fall back. If it does a short one, whoops, we're going to have long wavelengths. If it does a long one, we're going to have short wavelengths. So excited, and then emit. And then here comes all the things. Oh, let's just put abs in there. So they're the key words. We've got absorb, excite, electron, emit, and then the different ideas about wavelengths. So electrons absorb light energy, mark. This excites them to higher energy levels or shells, mark. They then fall back to their initial state, their ground state or their initial shell, word it however you like. When they do this, they emit light. The greater the fall, the shorter the wavelength, or the higher the frequency. So we get blue light. If it's a little fall, then you get longer wavelengths. If it falls all the way back in one go, then we get the same wavelength emitted as we absorbed. And I think that makes sense.